Going to help you practice dividing fractions with different denominators. Our first example, 7/8 divided by 1/4 or 1/4. So we ask ourselves, how many fourths are in 7/8? So the simplest way to model this is to generate equivalent fractions. One of the things I like to do, and I learned this from one of my former students, she was a whiz with fractions, and she always said to me, why don't you look at the smaller denominator first and see if it is a factor of the bigger one? In other words, can 4 go into 8s? Oh, yeah, it can. So she told me, she said, just keep the 8s and then convert this to 8s. So, oops, that's not 8. I'm trying to make an 8. We'll get to 8. So she told me a form of a whole. So multiply by 2/2 and you get 2/8. So we know 1/4 is equivalent to 2/8. So she said, well, just do that. Now we can draw these with the same denominator, much easier. So our dividend is 7/8. 1, 2, 3, 4, 5, 6, 7, 8. And then I finish. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8. I need to shade in 7 of those. Well, sometimes I go all the way to the last one so I know that I don't mess up. These aren't the neatest, but they'll get the job done. And I double check. 1, 2, 3, 4, 5, 6, 7 out of 8. So there we go. And I ask myself, how many sets of 2/8 are in 7/8 when the denominator is the same? Easy peasy lemon squeezy. Here's a set of 2/8. Here's a set of 2/8. Here's a set of 2/8. One left over. So it's 3 sets of 2/8. So it's 1 out of 2 needed for my full next set. So there we go. So I would say there are 3.5 sets of 1/4. There's 1 set, 2 sets, 3 sets. And there we go. So if we have these are 8s, we know that 2/8 is equivalent to 1/4. And how could I look at that? Let me see if I could get that in our picture. So here, if I had this into 4 equal size pieces, there are my 4 equal pieces. There's 1, 2, 3, 4. I should say there are, pluralize that. And we have, well, what do we have? We still have those 3 sets and 1/2 of another piece. So either way you could look at it, and that's where equivalent fractions come from. So there's one example. Let's do another example. Boop. All right, back to my favorite color, purple. Let's try another one, 11/12. Now, I picked this one, and as I'm thinking about it, I said, well, let's try not to go crazy with drawing. Again, say, is 4 a factor of 12, or can 4 go into 12? Yeah, so let's rewrite the first one, our dividend, 11/12. And we're going to convert this to 12ths. Well, 4 times 3 is 12. 3 times 3 is 9. So we have 9/12. I like to always rewrite my work. So now I ask myself, how many sets of 9/12 are in 11/12? Let's draw 11/12. I need 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that line was perfect. It's a little bit ugly, but it works. I know I need 11, so I'm just going to go there so I don't go too far. Sometimes my brain goes too far. 2/12, 3/12, 4/12, 5/12, 6/12, 7/12. Man, that's hard to say. 8, 9, 10, 11/12. There's my dividend, 11/12. My goodness, that is tricky to say. So I ask myself, I say, self, how many sets of 9 are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, when we circle, we have 1 set. So I have 1 set and I have 2. Oh, wow. I'm not even close. So I have 2 of the 9 needed to make another set. And remember, if you're confused, there's another way to find your denominator for your remainder. And I always think to myself, I'm circling sets of 9/12. I have 2 of the 9 left to make another set. Okay, so that's how you divide fractions. Oh, that was funny. It spun like that. That's how you model it, dividing fractions with different denominators. Hope that helps.